Welcome back to Windridge Woodcrafts. I'm Mike Shinley. We're going to start with some rough-sawn cherry and a little bit of walnut and turn it into a finished hand plane using both traditional tools and a CNC. I'm unloading some wood after a visit to my local sawyer. I went to go pick up some cherry, but like so many other things in life, you tend to grab a few extras along the way. In this case, the extras were some white oak and black ash. I had no immediate plans for either, but when your wood trafficker offers a deal, you take it. I need to cut out a section from this 37 inch by 7 inch by 4 inch block of cherry. The plane is about 11 3/8 inches long, and I'm just adding an inch or so to each side. There are a couple inches of rough-sawn wood on the end, so I mark that for removal, then add about 14 inches and mark that as well. We're at the bandsaw to lop off the rough-sawn end of this block. This is a bit of a balancing act since I only need to remove 2 inches, and the table extends about 8 inches beyond the blade, so I'm trying to keep over 2 feet of the block from tipping off the table while I push it through the blade. Yeah, this makes me feel old and clumsy. I need to cut this to about 14 inches in length, and since it's 4 inches thick, it's a bit too large for my table saw. And 14 inches is about 2 inches more than the gap between the inner edge of my bandsaw and the blade. My next best options are a chainsaw or a handsaw. I opted for the handsaw. After 4.5 minutes for the handsaw, I think I'll give the chainsaw a try next time. Now that we have this cut to length, we need to cut it in half vertically so we can glue it up as a book match after the CNC work. Book matching the wood this way will allow us to hide the seam of the glue up so it looks like it is done from a single block of wood, not two. It's an aesthetic thing that doesn't make a bit of difference in functionality, but it takes a little effort to make it look as nice as possible. Also, we're actually cutting a pair of planes out of this block. After cutting this lengthwise, we'll eventually cut the two pieces along the width so we can have a pair of book match planes. If you have any questions about this, I'm happy to address them in the comments. We need to flatten the boards to remove the bandsaw marks and make sure that the CNC cuts everything to the proper depth later. A few years ago I created a web form that gathers the CNC, board, and bit parameters needed to flatten boards to whatever height you specify. It takes those parameters and generates a G-code flattening program you can run on your CNC. You're seeing the results of that in action now. It's a small thing, but when you do this several hundred times, that can end up with a lot of time savings. At the moment, it has generated over 2,800 programs since I created it. I'll leave a link in the description. This is a 3M Extract 6-inch random orbital sander that was new on the market a couple years ago. It's much nicer than my old Porter cable sanders and doesn't have anywhere near the numbing vibration of them. This is another run of that flattening program mentioned previously, using a different stop depth this time. This program runs back and forth, lowering the depth each time. I've cut out the multiple depths since they all look the same, and if you've seen one flattening pass, you've seen them all. And a couple more minutes with the 3M Extract sander at 120 grit. This project was designed in Vectric's VCarve Pro software and is available for sale on my website. The interior of the hand plane is created with a single 1/4 inch spiral bit. If your CNC has an automated tool changer or ATC, I would suggest using an upcut bit for the 2 sets of alignment holes and a downcut bit for the rest of the interior. I don't have an ATC, so I just cut the interior with a single downcut bit. The exterior is created with 2 bits. The first is a downcut 1/4 inch end mill spiral bit. Since this is the exterior edges of the plane, it's important that the fibers are not pulled away from the wood, which would leave a splintered or tattered exterior surface. The second bit is a 1/4 inch downcut ball nose bit. For the same reasons as a downcut end mill, The ball nose bit should also be downcut to prevent tear out of the edges. We're starting with the interior of the hand plane. The first set of 1/4-inch holes are the alignment pins, which are used when the plane is flipped to cut the exterior. The second set of larger 3/8-inch holes are used to align the two halves of the plane when they are glued together. These are done in 2 passes, called roughing and smoothing, to provide better alignment for the glue-up. The blade bed and chip cavity are now being cut. The blade assembly rests against the bed on the right-hand side of the plane, and the wood chips are collected in the left-hand side of the cavity. A hole for the pin and a slot for the cap screw are the final cuts after the cavity is created. The pin goes into the center hole, and the slot allows the cap screw of the blade assembly to slide into the bed, so all the force of the wedge and pin are registered against the blade and bed. As you can see, we have perfect CNC weather today. It is 34 degrees inside the shop. I guess about 16 degrees outside the shop. Getting a nice snowfall. We got a couple inches so far this morning and just enjoying it. We're now cutting the exterior of the plane, starting with a 1/4-inch downcut spiral end mill. We cut the shape of the plane out first, leaving it connected to the frame of the wood with several tabs. The tabs act as connectors to the frame, so the majority of the milling can be done and still retain some rigidity. You'll see the shape profile is being cut out in 3 phases. The first phase cuts through the wood at full width, but a fairly shallow depth of 1/4 inch per pass. With the total depth of each half of the plane being just over 1 1/4 inches, this means it needs 6 passes to completely cut through. This will leave a fairly rough surface, so a smoothing pass is done next, which is done in 2 depths while only removing 1/100th of an inch each time. Finally, a finishing pass runs in the opposite direction of the smoothing pass, which is called a climb cut, and removes a final 1/100th of an inch of material. This all combines to create a very smooth cut that needs little to no sanding. We've switched to our 1/4 inch ball nose bit to round over the edges of the plane and to add some dimples for finger and thumb holes. The roundover is done by taking small increments along the sides and upper edges of the plane, leaving the bottom or sole flat. A downcut bit is used so the edges of the plane are not lifted away, which would cause splintering. The downcut pushes the wood fibers against the rest of the wood, which provides the support for the fibers to be sheared instead of lifted. This is also true for the dimples, where the wood fibers are cut toward the supporting wood. We're back to the bandsaw to cut off the tabs. There are 4 tabs along the sides and top of each half of the plane. I have a wide resaw blade on the bandsaw, which is not appropriate for cutting the tight curves along some of the tabs. Rather than replacing the blade, it's simpler just to remove the tabs in chunks. We use the Triton spindle and belt sander to remove the portions of the tabs still attached to the plane halves. The tabs are about 3/8 inch thick and 1 inch long, so they sand off pretty quickly. Once this is done, it's just a tiny bit of hand sanding, gluing it together, a little touch-up sanding, and then an oil finish. We also need a wedge to fit between the pin and blade assembly to provide pressure and hold the blade in place. These are about 3 inches long, 1 3/4 inch wide, and 9/16 inch thick. A quick CNC program takes care of 2 at a time from pretty much any piece of scrap. In this case, we're using some walnut as requested by the client. Well, that wraps up this project. Thanks for watching, and be sure to check out the description if you have any interest in the plans or plane for yourself.